Hi everyone. Today we are going to talk about audit analytics with statistics. So in today's lecture, we are going to cover some basic ideas and concepts of statistics. Please be advised that this course is not a statistics course, so we only cover some basic ideas, which is related to our audit data analytics. We all know that auditors use a large chunk of statistic models to analyze financial data. As a result, it's very important to understand these basic concepts of statistics. So, what is statistics? What are statistic models? How can we leverage them? What is their output? How can we interpret the output? So in this course, we try to cover those basic ideas. This course does not require any textbook. However, you might find it very beneficial to read some literature. For example, the first two books here are very helpful for people who do not have formal training in mathematics or statistics. For people who already have some mathematics or statistics background, the last book, Applied Linear Statistical Models, would be more useful for them to strengthen their background. So, what is statistics? Statistics is the study of how to collect, organize, analyze, and interpret numerical information from data. Even though we may not have realized it, you probably have made some statistical statements in your everyday conversation or in your everyday thinking. Statements like, I work for about 5 hours per day on average, and you are more likely to pass the exam if you start preparing earlier, are actually statistical in nature. So these two sentences are actually statistical in nature. So in general, statistics is a discipline which is concerned with designing experiments and other data collection, summarizing information to aid understanding, drawing conclusions from data, and estimating the present or predicting the future. So the two statements at the beginning illustrate some of these points. It's very important to distinguish between descriptive statistics and the inferential statistics. Descriptive statistics involves methods of organizing, picturing, and summarizing information from data. It tries to describe and summarize the data so that we can understand its essential features. While the inferential statistics goes beyond this. It tries to find patterns and trends of data and make some estimates or predictions. So the inferential statistics involves methods of using information from a sample to draw conclusions about the population. The inferential statistics, or we can call it as a predictive statistics, use the summary to make estimates or predictions about what is likely to be the case in other situations or maybe in future situations. So in statistics, when we talk about observations, we must understand these two concepts, populations and samples. Population is a collection of observations that represents cases and situations of our interest. For example, all company transactions for a selected period of time could be a population. Another example is all people who were born on January 23rd, 2000. However, sample is a selection from the population. So sample is just a collection of observations from the population. Example is a random collection of companies' transactions, or 30 people born on January 23rd, 2000. So in general, the main difference between a population and a sample has to do with how observations are assigned to the data set. So, a population includes each element from the set of observations that can be made. But a sample consists only of observations drawn from the population. It is preferable to use populations instead of samples. However, it's often either costly or impossible to do so. So the samples are used instead. For example, an auditor is often asked to issue opinions on the financial statements. The financial statements are linked to a company's business transactions. So the population here is all of the company's transactions. However, it is costly and impossible for the auditor to audit all those transactions. So the auditor could only select a portion from the population and investigate them. And based on these transactions, the auditor will make his or her statement. So the sample here is the transactions investigated by the auditor. Statistics is often used to generalize from a sample to population in a way that statistics tries to make more general statements from what they have observed in the sample. Of course, the statement might not be 100% accurate. It contains errors. Statistics helps us to estimate the probability of error to see how accurate the statement is. Sampling is a procedure for selecting sample elements from a population. There are many ways of sampling. Simple random sampling refers to a sampling method that has the following properties. The population consists of capital N objects. The sample consists of N objects. So all possible samples of N objects are equally likely to occur, which means every observation from the population has an equal chance of being selected. So it could reduce the sample selection bias, but is still a result of chance, which means what you choose may not represent the population very well. And there is another way of sampling called representative sampling or stratified sampling. Using this method, the observations selected are very similar to the whole population. A representative sample should be an unbiased indication of what the population is like. For example, in a classroom of 30 students in which half the students are male and half are female, a sample selected by representative sampling might include 6 students, 3 males and 3 females. When a sample is not representative, The result is known as sampling error. So using the classroom example again, a sample that includes 6 students, all of whom were male, would not be a very representative sample, because whatever conclusions are drawn from the studying of the 6 male students would not be likely to translate to the entire group, since no female students were studied. So the representative sampling method must ensure that observations that match the population on specific characteristics are selected, and the sample is similar to the population in a particular way. So once we have the data, we need to think about what is data. Basically, data is a collection of observations, and each observation can be represented by variables. In statistics, a variable has 2 defining characteristics. Number 1, a variable is an attribute that describes a person, place, thing, or idea. Number 2, the value of the variable can vary from one entity to another. For example, a person's hair color is a potential variable, which could have the value of brown for one person and black for another. Another example, so when we describe the transaction, the value, the date, buyer, seller, shipping date, and etc. can also be variables. For a person, the name, age, gender, income, and etc. can also be variables. Variables can be classified as categorical variable and numerical variable. Categorical variable can be also called as qualitative variable, and the numerical variable can be called as quantitative variable. Quantitative variable take values that are names or labels. For example, the color of a ball. For instance, red, green, blue. The color of a ball could be examples of categorical variables. For numerical variables, the variables are numerical. They represent a measurable quantity. For example, when we speak of the population of a city, we're talking about the number of people in the city. So it's a measurable attribute of the city. Therefore, population could be a quantitative variable or numerical variable. Numerical variable can be further classified as discrete or continuous variable. If a variable can take on any value between its minimum value and its maximum value, it can be called as continuous variable. Otherwise, it is called a discrete variable. Some examples can clarify the difference between discrete and continuous variables. Suppose the fire department mandates that all firefighters must weigh between 150 and 250 pounds. The weight of a firefighter could be an example of a continuous variable, since a firefighter's weight could take on any value between 150 and 250 pounds. Suppose we flip a coin and count the number of heads. The number of heads could be any integer value between 0 and plus infinity. However, it could not be any number between 0 and plus infinity. For example, we could not get 2.3 heads. Therefore, the number of heads must be a discrete variable. And the categorical variable can be further classified as nominal and ordinal categorical variables. Nominal categorical variable, there is no intrinsic ordering to the categories. For example, gender. Gender is a categorical variable having two categories, male and female. And there is no intrinsic ordering to the categories. Hair color is also a categorical variable, having a number of categories, such as blonde, brown, black, red, and so on. There is no agreed way to order this from highest to lowest. A nominal categorical variable is one that simply allows you to assign categories, but you cannot clearly order the variables. However, if the variable has a clear ordering, then that variable could be an ordinal variable. Suppose you have a variable, economic status, with three categories, low, medium, and high. In addition to being able to classify people into these three categories, you can order this category as low, medium, and high. So that's an example of ordinal categorical variable. Once there is a sample, so we have observations in the sample, the variables describing the observations. And so somehow it's important to characterize the value of the variables. As a result, we need to use distribution. So distribution here is something we use to characterize the variable in terms of its values. Here is an example, which is bar plot. So now you have a sample, and in the sample you have these observations. What the bar plot tells you is that you have a variable called risk value. And this variable can take three values, low, medium, and high. In 70% of the observations, the value of the variable is low. In about 25% of all the observations, the value of the variable risk level is medium. Finally, in around 5% of the observations, the value of the variable is high. This case is an example of observed frequency, which means you have data, observations, and based on the observations, you can construct distribution. In the future, we will talk about some theoretical frequency or theoretical probabilities. So, the theoretical frequency is the frequency that we expect or model or that we want to compare. So we will talk about them later. There are a large number of popular distributions used in statistical applications. For example, these distributions, the normal distribution, uniform distribution, t-distribution, f-distribution, and chi-square distribution, and we will talk about some of them in the future. Now, what we have discussed is statistics about the generalizing and summarizing the data. Now we try to calculate some features of the data and represent the data through these features. These features are also called measures. So let's discuss measures of central tendency. Central tendency is the tendency of observations centered around a particular value. Median, mean, and mode are three most common measures of central tendency. The mean is the average you are used to? Well, you add up all the numbers and then divide by the number of the numbers. Divide by the number of numbers. The median is the middle value in the list of numbers. To find the median, your numbers have to be listed in numerical order. So you may have to rewrite your list first. The mode is the value that occurs most often. If no number is repeated, then there is no mode for the list. So the following slides provide some detailed explanation and examples for these three measures of central tendency. For example, for the mean, suppose we draw a sample of 5 women and measure their weights. They weigh 100 pounds, 100 pounds, 130 pounds, 140 pounds, and 150 pounds. So the mean weight could equal 124 pounds. In the general case, the mean can be calculated using one of the following equations. This equation is called population mean, and this is the sample mean. This is the sum of the population observations. And the N, capital N, is the number of population observations. And here is the sum of all sample observations divided by the number of sample observations. So when statisticians talk about the mean of a population, they use Greek letter mu to refer to the mean score. When they talk about the mean of a sample, statisticians use the symbol x to refer to the mean score. So you should notice that. Median is the middle value of a sample. To find the median, we will arrange the observations in order from smallest to largest value. If the number of the observation is odd, it's the middle value. If the number of the observations is even, it is the average of the two middle values. So returning to the example of the 5 women, the median value would be 130 pounds because it is the middle weight. You can see like this. This is the middle weight. Okay, so mode is the most frequent value in a sample. For example, the distribution of 10 employees' ages as follows. So here the mode is equal to 38. Since 38 is the most of an age in the sample because it appears 3 times out frequent of 10. While central tendency like mean, median, and mode tells you about the center of your observations, it says nothing about the spread of the numbers. So we need the measures of dispersion. Measures of dispersion are used to describe the spread of the data or its variation around the central value. There are 3 measures: range, variance, and standard deviation. Range is the difference between the largest and the smallest value in a sample. For example, suppose there are 2 machines produce nails which are on average 10 inches long. A sample of 11 nails is selected from each machine, so it looks like this. Machine A has those 11 nails, and the machine B has these 11 observations. So the range is the same for both A and B because they are all the same. The largest number is 14 and the smallest number is 16, so the range is the same. But it's very crude. It's too crude a measure of variability. While it is very useful, but it is too crude a measure of variability. However, variance is the average of the squared differences from mean. So when we want to find out how much the data points are spread around the mean, we would like to use variance. To do that, we could find the difference between each data point and the mean and average these differences. However, we want to measure the differences to the mean regardless of the sign. Therefore, we could find the absolute value of the difference between each data point and average that. But for theoretical reasons, an absolute value function is not easy to deal with, so that one choose a square function instead. Finally, for yet some other theoretical reasons, we shall use not the sample size n to compute an average, but instead we will use n minus 1 to calculate the average. Hence, we will use this formula to calculate the data spread. So the formula is like this. So there are two symbols for the variance, just as for the mean. So the sigma square is the variance for population, and the S square is the variance for sample. It's very similar as what we have mentioned in previous slides. So in other words, the variance is computed according to the formulas. So here is the formula. Mu is the population mean, and the X bar is the sample mean. So the formula is like this. And the last one is the standard deviation. It's defined as square root of the variance and shows the average deviation from the mean. As with the mean, there are two letters for variance and the standard deviation. Sigma square is the variance for a population, as we just mentioned. So the sigma, which is the square root of the variance, is the population standard deviation. So S is the sample standard deviation. For example, consider the sample data 67534. Let's take a look how to calculate the standard deviation for this data. First of all, we need to calculate the mean. In this case, the mean equals 5. And then we calculate the variance, use the formula we just learned. It gives us 2.5. So finally, we can take the square root to obtain the standard deviation, which is 1.58.